You know that feeling, right? When a simple project starts to spiral into this huge, complex monster? Well, today, we're going to talk about a software nightmare that I bet a lot of you have faced. And, more importantly, we're going to talk about the one elegant design pattern that can save the day. So, let's get right into it.
So, let's set the scene. Meet Alex, the founder of a startup, Notify Hub. Things are going great. Their notification service is a hit. But then, success happens. And with success comes a flood of requests. Can you add mobile? What about email? We need SMS and Slack. Suddenly, Alex's codebase is groaning under the pressure, just about to completely break. This is that crisis moment.
So, how bad was it? Well, if they stuck with their current design, Alex's team was looking at creating over 100 different classes just for notifications. I mean, how does a simple feature get that out of control? The answer, believe it or not, is some terrifyingly simple math.
And here it is. This is the trap. It's called a combinatorial explosion. It sounds fancy, but the math is dead simple. The total number of classes you need is just the number of platforms you support times the number of notification types you have. Look, it starts out innocently enough, right? 4 platforms, 5 notification types, okay, 20 classes, manageable. But what happens when you get to 10 platforms and 10 notification types? Boom, 100 classes. You can just see how every single new feature, every new platform, makes the whole thing blow up.
So yeah, this whole nightmare scenario, it actually has a name. It's called the inheritance explosion disaster. And that's exactly what was happening to Alex. They were trapped, trying to force every little thing into one single rigid hierarchy. And it just wasn't working. It was becoming a complete mess.
Okay, so here's the absolute heart of the problem. Alex was tangling up 2 totally separate concepts. Think about it. You've got dimension 1, the abstraction. This is what the notification does. Is it urgent? Is it scheduled? High priority? Then you've got dimension 2, the implementation. This is where the notification goes. To your desktop, your phone, email. These 2 things have nothing to do with each other, but by creating classes for every combination, they were being welded together.
Right when things are looking totally hopeless, in comes Alex's mentor, Dr. Chen. And she sees the problem instantly. She doesn't just suggest a little patch or a quick fix. Nope. She offers a completely different way of thinking about the problem, and she gives it a name, the bridge pattern.
And this is it. This is the big aha moment. This is where we all get to discover the solution that's going to untangle this whole mess. It's not about building a bigger, more complicated hierarchy. It's about building a smart connection, a bridge. All right, so what exactly is this bridge pattern? Well, the textbook definition is to decouple an abstraction from its implementation. Okay, what does that actually mean? In simple terms, the terms we've been using, it's all about separating the what from the where. That's it. So you can change one without completely destroying the other.
And the change is, well, it's dramatic. Just look at this. On the before side, you have this tangled mess of classes like urgent desktop notification. But in the after, with the bridge pattern, it's beautiful. You have 2 clean separate lists. On one side, you have the abstractions, the what, like urgent notification. On the other side, you have the implementations, the where, like desktop sender. Now, you can just mix and match them however you want. Total freedom.
So you might be asking, how do these 2 separate things actually connect? Get this. It's basically this one simple line of code. This right here, this is the bridge. Instead of that rigid inheritance, the notification part, the what, just holds a reference to a notification sender, the where. It just says, hey, you, go do the sending part. It delegates the work. And that one simple change, it changes absolutely everything. Okay, so untangling all those classes is a huge win, right? But that's honestly just the beginning. The real power, the true magic of the bridge pattern is the insane flexibility you get when your code is actually running. Think about this for a second. Because you can swap out the implementation at any time, you can build some seriously smart systems. Imagine this. A notification tries to reach you on your desktop first. No answer? Okay, no problem. It automatically tries sending an SMS. Still no luck? Fine. It'll fall back to sending an email. This kind of dynamic, on-the-fly logic it's impossible when you're stuck in a rigid inheritance chain. Okay, but here's a question I'm sure some of you are thinking. What about a really common problem? You know, an email can have all this fancy formatting and attachments, but an SMS is, well, it's just plain text. How do you handle those differences without making another huge mess? Well, the pattern handles this so elegantly. It's a concept called graceful degradation. Your code can literally just ask the implementation, hey, do you support rich content? If the answer is yes, awesome. It sends the fancy formatted version. If the answer is no, no big deal. It just sends a simplified, plain text version. It adapts on the fly to whatever each platform can actually handle. It's brilliant. So at this point, you might be thinking, okay, cool for notifications, but what else? Well, this pattern is everywhere. Once Alex understood the core idea, they started seeing it all over the place, in software that we all use every single day. Just think about it for a second. Database drivers. You write one query in your code, and it can talk to MySQL, Postgres, or even MongoDB. How? That's the bridge pattern. Or UI frameworks. You have a generic window class, and it can be rendered on Windows, macOS, or Linux. Yep, that's the bridge. Graphics rendering. You define a shape one time, and it can be drawn using OpenGL, or at DirectX, or whatever. That's the bridge pattern at work.
So, fast forward a few years, Alex has mastered this. They're an expert now, and we get to benefit from all that hard-won wisdom. So the big questions are, how do you know when you should actually use this pattern, and how do you make sure you use it well?
So Alex came up with this really simple checklist, a little test you can run. First, ask yourself, do I have two independent things that are changing? Like, do they need to evolve on their own schedules? And then, here's the kicker. Would using inheritance cause that crazy class explosion we saw earlier? If the answers are yes, and especially if you need to switch how things are done at runtime, then yeah, the bridge pattern is almost certainly what you're looking for. And to really nail the implementation, Alex figured out a few key best practices. The absolute #1 rule is to keep that separation clean. Don't let the what and the where bleed into each other. You want to design a really stable, clean interface for your implementations. That interface then becomes a wall that hides all the messy, platform-specific junk, which is what allows for that super elegant adaptation we saw earlier.
But, you know, a huge part of being an expert is knowing when not to use your favorite tool. And Alex learned this too. Look, if you've only got one dimension of change, or if the abstraction and implementation are actually truly naturally tied together, then the bridge is just overkill. It adds complexity you don't need. It's a powerful pattern, for sure, but it's not the only pattern. And sometimes a much simpler solution is the right call.
So that brings us to the final question, and this one's for you. Take a look at the code you're working on right now. Where do you see those tangled dimensions? Where are the potential code explosions just waiting to happen? What bridges do you need to build to create those flexible connections instead of rigid, breakable dependencies?